Good morning, Dave Kenworthy, 20th of the 9th, 2021. This morning we're going to look at something that's very, very simple, but also very significant in terms of historical metrology. I'm going to show you how to use the meter to calculate the base length of the Great Giza Pyramid, and from that we can determine the Earth's circumference in miles, feet, inches and digits. And what we'll find is it's always the same number of digits, regardless of the length of the meter. And I've set the model up to show a meter length of 1. We multiply it by 50,000 because the Giza base is determined against 50,000 meters. In this case, the meter is 1 inch in length. So the Giza base is 50,000 inches. We want to turn that into digits, so we use Berryman's 54 digits in a meter, and we find there are this number of digits in the Giza base when the meter length is 1. And the digit, we divide that by 50,000 to get the digit. So there are 50,000 digits in this Giza base. To determine the Earth's circumference, we divide by the eclipse unit, which is 1760 divided by 1200. And the reason for this is we know there are 1760 cubits in the Giza base in inches, and we know there are 1200 cubits in the Earth's circumference in miles. So we can put any meter length we want to in here. So of course I'm going to put the base 100 meter in, which is 39.6. And what we find immediately is that when we multiply it by 50,000, we've got here the Sumerian cubit. That's a lot of Sumerian cubits. It might be 1 million, I'm not sure. Just divide it by 100,000 Sumerian cubits. So we can say that the pharaoh wanted the Giza base to be scaled against 50,000 meters in this instance. And his scribes would tell him that there were 54 digits or 55.555 recurring shuzi in the meter. So dependent on which unit was being used, there'd be different interpretations of the Giza base. They'd also explain to him how the Earth's circumference would be linked to the Giza base. He'd know all this. That's why he's the pharaoh, because the pharaohs know all these key mathematical ratios. And then we look at the digit, because we divide the base by 50,000, and then we look at the Earth's circumference in miles. It's 25,000 miles, which is the base 100 great circle. It's 13200 feet, and we know that if we divide that by 1.1, we're dividing by Indus Valley feet. It's 1584 inches and 2160 digits, always 2160 digits, and we can test that now because we're going to use the modern meter. And to prove that this is working, we know that the modern meter is giving us this number of inches, and that has to be 40,000 for this model to be working. 40 million, sorry, and there it is, 40 million. This is what Berryman tells us in the Great Circle. There are 40,000 meters, regardless of the length of the meter. Now let's have a look at Berryman's 2 meters, because he gives us 39.75. And we're very familiar with those numbers by now and that digit. And he also gives us 39.366, and there's a 0.729 digit. The next presentation is going to be about understanding these digits, in particular this one. But this model that's not working, see? 39.39995936. That's because I'm using the modern metre in that calculation. So I've got to change that to 366. And it works every time. So that's it. That's all I'm talking about now. This afternoon I'm going to look at this digit here, which is, it looks like a very simple unit, but it's colossally complex, this unit, and we're just going to look at this individual unit, because until we understand this, we won't understand historical metrology. So that's it for now. Thank you.